Hello everybody, this is Vasvi from AtHome. We have already learned the circumference and the area of the circle, right? In this video we are going to learn about the sectors in a circle and how to find the area and the perimeter of a sector, length of the arc, etc. etc. Okay? First of all, let me tell you what a sector means. Sector of a circle. A circular region enclosed by two radii and the corresponding arc is called the sector of the circle. See, if you have a circle like this and if the center is denoted as O, you just take any 2 points on the circle like A and B. So from the O, if you draw two radii, OA and OB are the radii, right? This is the radius and this is also a radius. From the center to any point on the circle, if you draw a line, that is going to be the radius. So the area enclosed between the two radius, that is this area, okay? This area between the two radius and the arc, corresponding arc, the arc over here, okay? So this portion, this is what is called the sector, understood? So here in this picture you see it is like a circle cut, like when you cut a piece from a pizza, okay? What happens? You get a small sector here. This one is called the minor sector, okay? The small one over here, the sector you see smaller is minor sector, and the other sector over here, okay, this one would be the major sector, understood? This is major because it occupies major portion of the circle, and the minor sector would occupy only a little portion, okay? So both the major sector and the minor sector will have an angle, okay? It makes an angle at the center. So here you have an angle, okay? For the minor sector you have the angle smaller than the angle of the major sector which you have, okay? For the major sector this would be your angle. So I hope you understood what a sector is, right? You have got a formula for finding out the area of the sector. Here I have drawn the circle again, and I have taken 2 points A and B. So this is an arc made, right? For the area of the sector, it is so simple. The sector is a portion of the whole circle, right? We know that the area of the circle is pi r square. So this sector is a portion of, for a full circle it is 360 degree, but this portion has only theta degree taken, right? So the formula would be theta degree out of 360, okay, times pi r squared. And since it is an area, you will have square units as the unit, okay? Now, the length of the arc. To find the length of the arc, length, I told you it is the border, right? AB, this border. So, it is something to do with the circumference of the circle, right? So, here it is theta over 360 again, because it is only that portion of the arc you are taking. And you use the circumference formula here, that is 2 pi r, okay? So for the area of the sector you use the area formula there, and for the length of the arc, since the length of the arc is on the circumference of the circle, you can take the circumference formula here, okay? And this would be in just units, no square units, okay? Just units. Now the perimeter of the sector. So this is the sector, right? When I say just sector, it means the minor sector. If it is a major sector, they would specifically mention it in the problem, okay? So here this is a minor sector given. The perimeter would be the two radii plus the arc length, right? So I can say 2r plus arc length, length of the arc will give you the perimeter of this sector, understood? So I just mentioned all the formula here. Now let us see how it is applied in the problem. Find the area of a quadrant. They've said it is a quadrant of a circle whose circumference is given. Okay. So you have a circle here. So I roughly draw a circle. So they say it's a quadrant, right? So the sector is like a quadrant. That means it makes 90-degree angle. Okay. So the angle here is 90. Normally in the problems they would give you the angle. If it is not here, they haven't given you directly. They just gave you a clue that it is a area of the quadrant. So for a quadrant it is 90-degree, the angle is. And they say the circumference is given, whose circumference is this. You need to find the area of the quadrant. Okay. So here the circumference is perimeter of the sector, right? So I say 2 pi r. Okay. We don't know what is r. Let us find out, because they have given you the circumference. This is given as 22. Okay. So what is your r? That implies, so your r would be equal to 22. You already have on your right side. You bring the numerator to the denominator when it comes to this side of the equal to side, and this denominator 7 would go up. So this is cancelled. So my r is 3.5. Okay. Centimeters. So I got my r. Now I can find the area of the quadrant. So area of quadrant is equal to, we know that the angle is 90-degree, right? So the formula is theta by 360 pi r square, right? So this is theta here is 90-degree divided by 360 times the pi, we can take it as 22 over 7, and r just now you got it as 3.5. If you want, you can just leave it. I just take it at 7.7 by 2. Okay, 7 over 2 centimeters. So my r square would be 7 over 2 times 7 over 2. Okay. So we can solve this. If you want, you can use a calculator and solve. So you would get the answer as 9.625. This is area of the quadrant, right? So I write it as centimeters square. Okay. So that would be the answer for this. Now let me go on to the next question. Here they say the length of the minute hand of a clock is 14 centimeter. So just see, imagine the minute hand of a clock. So your clock is circular in shape, and I just draw the minute hand alone. So the length is, say for instance it is at 3. Okay, at 3. So this length is 14 centimeters. So I can say that my radius is equal to 14 centimeters, right? They ask you the area swept by the minute hand in 5 minutes. So in 5 minutes, in the sense it would be here at 4. Okay, since I have taken it as 3. So this angle you should first find out, because to use the area formula we need the radius and the theta, right? The theta is not given. So let me find out the theta first. See, it is for 60 minutes you have 360 degrees, right? So for 1 minute it would be like 360 divided by 60. So that's 6 degree. Okay. So 1 minute is 6 degree, but here you have 5 minutes, right? 5 minutes, it would be like 6 times, for 1 minute it is 6 degree, right? 6 times 5, so that is going to be 30 degree. Okay. So we got the angle now. So the theta is equal to 30 degrees. So let me find the area now. Area of the sector, because it is going to sweep the complete sector, right? Of the sector is equal to, the angle is 30 degree, 30 divided by 360 times pi r square. Pi is 22 over 7, and the r is 14 times 14, right? R square is 14 times 14. So you can just calculate. This is 30, right? You can use a calculator instead. So this goes here 12 times. So this will go here 6 times. And just keep doing it. So 6 will go thrice, right? Here, and it's 11. So you have 154 over 3 centimeter square. Or you can just write that as 51.3 centimeter square. Okay? And the final question here. A horse is tied to a peg at one corner of the square-shaped grass field. So let me draw a square-shaped grass field. So it's square, okay? All the sides are 90 degrees. So you have a peg at the corner. So you have a peg here. Just imagine you have a peg here. The sides are 15 meters. So let us put the sides here. All 15 meters each, okay? The horse is tied and the rope length is 5 meters. So the length of the rope is 5 meters. So that's your radius. Radius is equal to 5 meters. You need to find the area of the part of the field which the horse can graze. Since the length of the rope is this much, the horse can graze only up till this area, right? It can't go beyond that because it is tied up. So only as long as the rope, it can go with the rope, only that much area it can graze. So that area will look like a sector. So you can use the sector formula here again to find the area. So the first answer would be area grazed, right? Would be, the angle is 90 degree because it's a square, right? 90 over 360 times pi. Pi is 22 over 7 times r is 5. The length of the rope is 5 meters. So that will give you, that is equal to 19.6 centimeters square. Okay? You have another part in this. The increase in the grazing area, if the rope were 10 meters long instead. Okay, now the rope is 10 meters. Okay, so area grazed would be equal to, instead of 5 you just put 10. Okay, all the rest are the same. 90 degree by 360 times 22 over 7 times 10 times 10. Okay, so it can graze 78.6 centimeters square. Okay, now it can graze this much area. So the extra would be the increase in the area grazed. 78.6 take away 19.6. So that would be like 59 centimeter square. So this would be your answer. Hope you all understood how to do with the area of sector and length of the arc as well as the perimeter of the sector, right? Thank you for watching this video. See you. Bye.